Okay, I'm back. I'm on page 244. I'm on the part you can see, picking up right where I left off. So new problem. We're going to use 50, 100, and 1,000 cylinders. The number doesn't even matter once you set it up, right? Because you're going to go to your calculator, you're going to set up a function, probably as a function of n, and you'll just plug in 50, then 100, then 1,000. So that's not a big deal. To approximate the volume of the solid form by rotating the region enclosed by the given curves about the x-axis. Your work includes a sketch, delta x, x sub I, and a summation. So that's what we got to do. So I'm probably going to do the first two here and then come back and do the next one and the next one because they're a little more involved. They're like slightly different. So let's start with this one. So sketch it. Okay, so 3 here, and then if x equals 0, 3, wait, what? This is not accurate at all. You gotta read the problems, people. People being me. So we're going from -1 to 9. All right, so I know that 3 is important. So it turns out that all that really matters is, well, like none of it really matters in this picture. Like I need to definitely know where I am at -1 and where I am at 9. So you want to get a representative picture. So -1 gives me 3 minus 1/2, whatever. It's like here. And then 9 is going to be so big that I'm going to have to draw all over this. So we're going to go like that. So this is my region. All right, not great, but not terrible. So this is the function y equals 3 plus x over 2. We're going from -1 to 9. So let's think. Delta x is going to be where we stop, which is 9, minus where we start, which is -1, divided by n. So it's just 10 over n. X sub I is going to be where we start, -1 plus I times delta x, so 10 over n. So the volume as a function of n, so I'm going to say v of n, is going to be the sum. I don't know, why am I doing everything over here? It seemed like a good idea. There's like a lot of space, but where's my 9 going? Hold on. Let me try that again. So I want to lasso, using the lasso tool, move things around. Okay, it's going to be the sum. Still no lasso tool. Okay, the sum from I equals 1 to n of pi. So I should put, we're going around the x-axis, pi f of x sub I, that's the radius. I have to square the radius, delta x. So really the key thing here is this information, because you're inevitably just going to memorize this. I mean, it's pi r squared h. It's the volume of a cylinder. Then you add up all the cylinders. That's all that summation is saying. But in my experience, you end up just memorizing it for a while, and then eventually it clicks. And that's great, because when we come back to it in calculus next year, you'll be like, didn't we do these things in analysis? And I will say, we did do these things in analysis. All right, so to the calculator. All right, I'm going to start a new document. Okay, biggest mistake I see people make is to forget the function, which if you remember a couple videos ago, that was me. I was that guy. All right, v of n, u of n, colon equals summation. Even I do not like, you can type in a summation without using the template. It's terrible. You have to do like sum, sum, sequence, seq, and then parentheses, then type in this whole sequence. It's like a nightmare. You used to have to do that on the TI-80. I guess I use a TI-83 plus silver edition when I was in high school. It was like top of the line. All right, so here, and all right, so pi times f of x sub I, I'm looking at my paper, is 10 I over n. Got to square that radius, times, got to put in the height, 10 over n. Okay, so this is our volume. And now what I want to do is I want to use it. So it's a little unnerving because I don't have I don't have an answer key here. So I'm thinking these are right. 10, 1, no, 50. What do I want to do? 50, 100, 1,000. 1, 2, 3. Like this. And then while I'm here, I might as well find the exact value, although I do not think the problem asks for it. This, if n goes to infinity, I should have just used a button, infinity. You can type infinity. It goes from like italicized to justified when you get it right, when you get some predefined thing of v of n. Get an exact value, let's get an approximate. Super close. So the difference between 1,000 and infinite number is like less than 1. But still, you want to do it. All right, so let's switch back over, copy these in, make sure our notes look good, and then I will do the next problem. So these are like, once you know what you're doing, you just set them up and knock them down. There's not a lot of thinking once you've already thought it through. So v of, what are we doing here? V of 50 is approximately, approximations because they're not equal. Oh no, wait, v of 50 is equal, but the actual volume is only an approximation. No, this is still an approximation because it's decimal. I'm having some sort of conversation with myself where I've settled on approximation. 866.608. V of 100 is approximately, for the same reasons I just talked to myself about. 8, okay. What are we doing here? We're like moving, but not writing. 858.715. And then V of 1000 is approximately 851.634. And if you wanted to, you could find the exact value. I don't feel a pressing need to do that. Man, those are tiny. I hope you can read those. I expect you probably can. Oh, they're not that tiny because they're like blown up. They're tiny when I like zoom in, zoom out, zoom whatever. When I make it look normal, they're very small. All right, let's do the next one. So x squared plus 1. So you'll find that other than like your sketch is going to be different, your delta x is different, your x of I is different, but your summation is exactly the same because you kind of like write it in terms of things. So let's sketch this. We're going from -2 to 1. So the last one you could actually find geometrically because you can do like a cone minus a smaller cone and get a frustum. This one, you cannot do that for. Probably there are ways of like getting this, I think, that like ancient mathematicians kind of like knew and worked out. Like, I'm sure Archimedes would just laugh at this notion and be like, oh, I don't know, you cut this off and throw it in a sphere and a cone and somehow it comes out. That guy was good at math. Good at like intuitive math, super intuitive guy. Cool guy, like did all the like the battle weapons or whatever, said he could like pull ships out of the air or whatever, out of the sea and like flip them over. Killed by a Roman soldier. I think I'm talking about the right guy. He was like, he was from Syracuse and they were being invaded by the Romans. And when the Romans got there, they had one order. Well, they probably had two orders. One, like conquer Syracuse. And two, I think Syracuse is right. Two, bring me Archimedes. Like, don't kill him, bring him to me. And Archimedes was like super involved with what he was doing. He's like drawing a picture on the ground in sand like they did. And the Roman soldiers is like, who are you? And he's like, don't you bother me. I'm like doing my work. And the Roman soldier is like, oh yeah, well, I'm gonna stab you. And he stabbed him, and that's how he died. It was an accident, kind of. I'm sure the Roman soldier was punished for that, but let's get back to this problem. So this is our region. You should look up that story. I think it's true, or at least I think it's the true story that people tell. It might be apocryphal. It might not actually have happened. I'm pretty sure it did, though. All right, so we got to get a delta x. So that's going to be 1 minus -2 divided by n, so 3 over n. We got an x sub I, which is going to be -2, so where you start, plus I delta x, so 3i over n. We're going to have a summation, so our volume as a function of n. This is an approximation of the volume using n whatevers. It's going to be the sum from I equals 1 to n of pi, the radius, which is f of x sub I, squared, pi r squared, and then the height, which is delta x. All right, let's use a calculator While I'm here, why don't I write down v of 50 is going to be a product of 50? Where did I even get that? V of 50. Yeah, that's what I'm doing. Am I actually doing that? What are the directions? Yeah, okay. It's so weird that I didn't just like follow like an exponential pattern or something. 100. Well, maybe I was going to double here, but then no, because we're going to do 1,000. All right, I'm going to come back, fill these in, and I'm going to cut this video. So I'm going to enter this on the calculator and see what we get. So switch over to the calculator. Here I go. And there it is. New problem this time. Doc 4, enter, calculator page. New function, x squared plus 1. Volume is a function of n. Summations, you're crazy if you try to type them in. As sums of sequences, I goes from 1 to n. Pi, so let's not forget that. F of x sub I, so x sub I is going to be -2, which is where we start, plus I delta x, so 3i over n. Got to square the radius, and then do the height, which is 3 over n. V of 50, V of 100, V of 1,000. Okay, and then if you want, you can find the limit. You should use the template. It's kind of faster to do this. Gives me exactly 78 pi over 5, which we're not asked for, but I think it's really cool that we can do that, and so we should. That's the exact value of this crazy shapes volume, right? You're going to rotate it. You're going to get some weird looking thing. It has an exact volume of 78 pi over 5. Let's go back to the notes and fill these in. What am I doing? Going back to the notes. Here we go. Whew. Got it. All right. So we got the following values. 47.075, because we're rounding to 3 places. 47.075. And then we got 48.031. And then we got 48.910. And those are our approximations. So what I'm going to do is end here, come back in the next problem, because the next problem is a little bit different. And then probably finish this page in that video. Maybe. We'll see. But anyway, I hope you are finding these helpful.